Then there will be three things that we'll be focusing on. First of all, variable resistor. Second, thermistor. Third, light-dependent resistor. So resistor, as we all know, basically is just determine like, oh, how many resistance the circuit has. I can have a fixed resistor, this one, and I say my resistor is like 5 ohm. And that's my fixed resistor for the entire circuit. Okay. But what is variable resistor? Variable resistor just means that I can vary the resistance of my resistor. So now I want my resistor to be like maybe 10 ohm, or I want it to be less resistance and I adjusted it to like 2 ohm. Okay, so I can change the resistance. Change resistance. And it's represented with an arrow in the middle. Then for thermistor, I will take it as remember it as like temperature will affect the resistance. Okay, so it's the same thing. Now I want to adjust my resistance, but what do I do? Do I just adjust it accordingly? No. For thermistor, it's I adjust the temperature so that I can adjust the resistance. Okay, so there is like 2 steps to it. You adjust the temperature and then you adjust the resistance. Okay, so here you can see when the temperature increase, okay, maybe now I want my resistance to be lower. So what do? I increase the temperature, because when I increase the temperature, the resistance decrease. So you can see they are inversely proportional. And this is a relationship that you need to remember, okay? Then for LDR, light-dependent resistor, it's like almost the same thing as thermistor, but now is the light intensity that affects the resistance. Okay, so same thing. Now I want to adjust my resistance. Do I just adjust it immediately? No, I don't. I adjust the light intensity. I adjust the light shining on it. Okay, I adjust the light shining on it, then it will affect my resistance. So when I have more light shining on it, my resistance will decrease. So you can see for LDR and thermistor, they are both like the light intensity and the temperature, they are both inversely proportional to the resistance. Okay, inversely proportional. And then for this part, just take note, for lamp, right? When I have more current, then what will happen to my temperature? And I have more current, I will just have like, it will just get hotter for my circuit, so my temperature will increase. Okay, so these are the 3 relationships that you need to remember. Okay, I hope you wrote down already, because I'm going to move on to the next one. Okay, so okay, so for the next one, basically, okay, this part is okay. Don't really go through. I'll go through this part first. So for current, just take note, these are the questions that will come out like during MCQ, especially. They'll just ask you what's the difference, that what's the direction of the current when it's convectional current. So just take note, for convectional current, it always flows from the positive back to the negative terminal. Okay, positive to negative terminal. But for electron flow, it will always flow from the negative to the positive, because electron always come from the negative side, right? So it will flow from the negative to positive. But for current, it's the positive to the negative. So just don't mix up these two. Okay, so now there will be like practice questions, and we'll give everyone some time to try to do it. Okay. I think for these 3 questions, we can take around like 3 minutes to try to do. Then after 3 minutes, I'll go through the questions, like each of them. Okay, so you just try on your end first. I'll set a timer on my end, 3 minutes. Okay. Okay, guys, so 3 minutes up. I will just go through slowly. So if you never finish yet, it's okay. Just try to, follow and note down any question if you have, okay? And sorry, I'm a bit sick, so my voice is a bit, and thank you for telling me. Sorry, everybody. I was saying that if you think that I'm speaking too fast, feel free to just, text me, in the chat, for example, that I'm speaking too fast, then I will slow down. And also, if you have any questions after, like, if you haven't finished these 3 questions, it's fine, because I'll just go through slowly, and you can try it after the class as well, and just let me know if you still face any difficulties, okay? And yeah. I will slow down from now on, because just now one student texted me and said I talk a bit too fast, so I will just slow down for everyone. Okay, hope that this pace is better. Okay, so let's go through question number 1. See the value of I1 and I2. So what to do? What formula can we use, right? So in this case, what do we have? We have resistance, we have current, right? This is current, this is resistance. Okay, and now I'm finding of I1 and I2. Yeah, I'm finding I1. Then what do I do? So what formula can I use in this case? V equals to IR, because I have resistance, I have current, and I can find potential difference because I have current and resistance. Okay. So in this case, first of all, I find what is my total resistance first. In this case, they are in parallel, right? So to find the total resistance, is 1 over 10 plus 1 over 5 inverse. Okay, this is how you use, how do you find resistance when it comes to parallel? So what will you get? Type into my calculator. 1 over 10 plus 1 over 5. And you inverse it, you'll be getting 3.33 ohms. So this is your total resistance. Okay. And I can find my total current. My total current is here, 4 ampere. So I can find my total voltage for this part of the circuit. Okay. So V equals to IR. My V is unknown. My I is 4. My resistance is 3.33. So it's 4 divided by 4 times 3.33. So my potential difference is 13.32 volts. Okay, for this part. And then this is a parallel circuit, okay, for this part. Like, we don't even need to look at this part at all, actually, if you realize, like, it doesn't matter. We can just calculate using this part. So you calculated the potential difference is 13.32. And this is a parallel circuit. So means that the potential difference is the same. They don't add up to be 13.32. Each of them equals to 13.32. So for this part, my potential difference is 13.32 volts. And then for this part also, 13.32 volts. Okay, then now I can find the current flowing through, like I1 and I2. So V equals to IR again. My V is 13.32. My current is unknown. My resistance for this is 10, right? So my I equals to 13.32 divided by 10 is 1.332 ampere. And how much is my I2? This is my I1. My I2 is just, my total current is 4, right? So I just take 4 minus 1.332 equals to 2.668 ampere. So you round up to 3 SF for both of them, it will be 1.33 ampere and 2.67 ampere. Okay, so that's how you find the I1 and I2. Okay, so next one. State the value of R3. Okay, this question, I'm sorry, there's bug, because they already give you R3, like 3.5 ohm. So this part you just for question 2, just ignore it. Okay, there's bug. Okay, then for question 3, find the total resistance of the circuit. Okay, just make sure y'all can see question 1, just in case you haven't finished copying. Okay, then for question 3, there is parallel and there is series, if you realize. So this part, R2 and R3, they belong in a series, okay? But then R1 and R2 and 3, they are in parallel, right? So how do I find the total resistance? So total resistance will be equals to, okay, for the series, what I find the resistance for the series first. So it's just 3 plus 1, which is 4 ohm. Okay, so now I need to find my parallel. My parallel will be, I can't get this. Okay, my parallel will be 1 over 1 plus 1 over 4 inverse. Okay, 1 over 1 plus 1 over 4 inverse is 0.8 ohms. And this is my total resistance. Okay, so this is how you calculate when the circuit has parallel and series together. Okay, I hope everyone is doing okay. If not, you can just text me afterwards, okay? Then we will move on now. Okay, wait. Before I move on, is there anyone who want to ask any question? Or like you just want me to pause on this page for a bit longer? Just like raise your hand. And I'll just pause for another 1 minute before I move on to the next one. If not, I'll just move on now. Okay, everyone seems like it's okay. Okay, I'll just move on. Okay, then for this question, question 14. Which circuit has the largest current flowing at point X? Okay, so for this question, how do we do it? Largest current. And from what I see for A, B, C, D options, what can I calculate is only resistance, right? So largest current, I know that means that my resistance is the smallest. Yeah. And point X is the total current, if you realize, because it comes out of the battery itself, right? Total current. So they're asking you which one the total current will be the largest, which means that which one the resistance will be the smallest, because that's what you can calculate. Okay, so for A, how do I calculate my resistance? I just take 1 over 100 plus 1 over 100 inverse, because this is for this part, right? It's for this part, which is in parallel, plus 100. And this is in series. Okay, so what will I get? 1 over 100 plus 1 over 100 inverse plus 100. I'll be getting 150 ohms. And then for B, it's just all in series. So I just 100 plus 100 plus 100, which is 300 ohms. Okay, therefore, they are all in parallel. So I just need to 1 over 100 plus 1 over 100 plus 1 over 100 inverse. So what will I be getting? It's just 33.33 ohms. Then for D, these two is in series and this two is parallel with this, right? So it will be, my series one is 200 ohms. So when I calculate the total, it will be 1 over 100 plus 1 over 200 inverse. 1 over 100 plus 1 over 200 inverse. I'll be getting 66.67 ohm. So it says the question asks for the largest current, which means the least resistance, and in this case, C will be my answer. Okay? Anyone has any question? Okay. Sounds good. Okay, then we continue. Question 15. So the filament of one of the bulb breaks. So what happened to the voltmeter reading and ammeter reading? So what if one of my bulb doesn't work anymore? What will happen to my voltage and also my current? Because that's what voltmeter measures and that's what ammeter measures, right? So I think I'll give you all maybe 30 seconds to think about it first, then we'll go through. Okay, so just 30 seconds. Okay, so I hope that you have read the question and have a bit of idea how is it going to be like. So how do we do it? So what do I usually do, right, is when one of the filament breaks, means that actually every lamp, they have their own resistance. Okay, so just take note. Every bulb has resistance. So this question says the filament of one of the bulb breaks. So basically, for example, now all my bulb has a resistance of 2 ohms. Okay, because they're identical, right? Two similar light bulb is mentioned here. So it means that they have the same resistance also. So it's like 2, 2, 2. Okay, so one of them break. So what will happen when one of them break? Okay, now just take as like 3 of them work perfectly fine. Okay, so what is the total resistance? It'll be 1/2 plus 1/2 plus 1/2 inverse, right? So it will be 1/2 plus 1/2 plus 1/2 inverse. So it will be 0.67, okay, 0.67 ohms. And now one of them break. Then what is my total resistance? It will be 1/2 plus 1/2. That's all. We got 2 left, right? So 1/2 plus 1/2 inverse, it will be 1. So you'll realize actually when there are only 2 filament lamps, the resistance is even higher. Okay, so the total resistance is higher. When total resistance is higher, what happened to my current? When my resistance is higher, my current decreases. So that eliminated A and that eliminated C. Okay, so when it comes to this kind of question, it's better if you could sub in values yourself. And also just take note, every bulb has resistance. Okay, then what happened to the voltmeter reading? And for voltmeter, just take note, because they are parallel, right? They share the same voltage throughout. Okay, they share the same voltage throughout. So it will be unchanged. Okay, so it wouldn't change. For example, now, I have a series like that. My total voltage is like 3 volts. Okay, so how do I get 3 volts as my total voltage? It's probably my voltage for this light bulb is like 1 volt, and my voltage for this light bulb is 2 volt. So 1 volt plus 2 volt give me 3 volt, and this is in series. Okay, but for my parallel, all of my row, they share the same voltage, right? So it's like that and like that. So if my total voltage is like 3 volt, my this row is 3 volt, my this row is 3 volt. Even if one of my bulb is broken, my another one is still shares the voltage of 3 volts. Okay, so take note, for parallel, the voltmeter doesn't change even if the one of the light bulb breaks. Okay, so the answer will be D. Okay, I hope everyone is okay. Any questions so far? Okay, then I will move on. Okay, for question 27, which arrangement gives a total resistance of 12 ohms between X and between Y? So same thing, how do we calculate our resistance? We just do it here again. So it's just for question A, for option A, it's just 1/12 plus 1/12 inverse, because they are both in parallel. So it's just 1/12 plus 1/12 inverse. I'll be getting 6 ohm. And then for question B, it's just 1/6 plus 1/6 inverse. And we're getting 3 ohm. Then for option C, it's just 1/6 plus 1/6, because these two are in parallel, plus my 6, which is in series. So basically is 9 ohms. Then for my option D, it will be 1/12 plus 1/12 inverse plus 6. So 6 plus 6, 12 ohm. So the answer will be D. Okay, pretty straightforward, just sub in formulas. Okay, then moving on to question 28. It's relating to this formula. Okay, can I get a show of hands? Who hasn't seen this formula before? R equals to rho L over A. Who hasn't seen it before? Okay, well, I think us. Oh, okay, there are some of us didn't see it before. Okay, no worries. So we'll go through what is this formula about. Okay, so what does R mean? So R is the same thing, resistance. Okay, what does L means? L means length, and the SI unit is meter. Okay, take note. And then what is A? A stands for area. Okay, and then what is rho? Rho is the resistivity of material. Okay, so what does it mean? Basically, usually we'll use this formula when we want to find the resistance of a wire. Okay, because a wire, there's the length and there's the area of the, like how thick is the wire. And also what wire is this? Is it a copper wire, a nylon wire, or whatever? Okay, so the resistivity of material matters in this case. So this formula basically just tells you how do we find the resistance of a wire most of the time. Okay, so in this case, question 28 is a little bit trickier. And let me think, should I give you all like maybe 1 minute to try it out yourself by using this formula? Okay, I'll give you all 2 minutes to try out this question yourself by using this formula, and we'll go through after the 2 minutes, okay? Okay, for those of you that haven't write down whatever I wrote over here, I suggest you write it down first because I'm gonna erase them and do the working for question 28, okay? Okay, so it has been 2 minutes, so let's go through. I'll be erasing. Okay, so let's go through. This is a question that a lot of students cannot get it initially, but it's a very standard question that definitely will come out during O-level. So it's very, very important. So please, please, please take note of this kind of question, okay? So like what I said just now, the formula that we use is just this. R equals to rho L over A. Okay, so in this case, it say a wire has a resistance of 8 ohms. So this is, we call it like wire 1, for example. Wire 1 has a resistance of 8 ohms. So it will look like that. 8 equals to rho L over A. Okay, this is my wire 1. And then for my wire 2, it has the same material. Okay, so take note, when they say same material, it means same resistivity. Okay, means that my rho is the same. And it will look like, okay, it says we have same material, double the length and half the thickness. So R equals to rho L over A for wire 2. So my R, I don't know yet. My rho is the same, so it's rho. And then my L now is double the length, so it will be 2L. Okay, for the thickness. It says the thickness is half the thickness. Okay, so take note, half the thickness and half the area is different. You will look at, you will see other questions that say, so if it says half the area, then your A will be half A, right? But it says half the thickness. So how do we form A? A is actually of a wire. Wire is circular, right? So how do you calculate the area of wire? It's pi r squared. Okay, so it says half the thickness, it will be half r, and you square it. Okay, so this is what it means by half the thickness. So what will my A for my wire 2 looks like? Pi 1 over 2 square, which is 1 over 4, 1 over 4 pi r squared. And this is how my wire 2 would look like for the resistance. And then I can simplify it by r equals to rho, and then 2 divided by 1 over 4. Okay, 2 divided by 1 over 4, it'll be 8. So 8L over pi r squared. And then continue here, r equals to 8. I move the 8 in front, rho L over pi r squared. Pi r squared represent what? A, right? So looks like that. Okay. Then do you realize this part is the same as here? And here equates to 8, right? So I just need to sub this to 8 because they equate to each other. It will be 64 ohms. And this is my resistance for wire 2. And my answer is D. Okay, hope everyone get it. Basically, there are a few things to take note. First of all, same material means same resistivity. Okay. Second of all, if it says half the thickness, take note, it's not half the area. You are not halving the area. You are halving the radius, which is A equals to pi r squared. Your r should be half to half r and not r. Okay. Then afterwards, you just manipulate accordingly and you will get the answer in the end. Okay, I will give everyone 10 seconds to like maybe copy this down or like take a picture before I move on to the next question. Okay, if you have any question now, feel free to just type in the chat also or unmute yourself. Okay, if not, I'll just move on. Okay, so I'll move on. For question 32, okay, I see. Let me erase a bit first. Okay, for question 32, it says the brightness of the light falling on the LDR is increased. Okay, so just now we said, right, LDR is basically the lightness, the light intensity will affect the resistance. And when the brightness increase, what will happen? So let's recap by looking at the relationship just now here. So when the light increase, the resistance decreases. Okay, so we go back to the question. So it says a light increase, right? Light increase, which means my resistance for my light dependent resistor decreases. Okay, so which row shows what happened to the reading on the ammeter and voltmeter? So when my resistance of this light dependent resistor decreases, and this one is my fixed resistor, right? So it means that it has a fixed resistance. It wouldn't change. For example, this one I have like 3 ohms. Okay, and then initially my light dependent resistor has 3 also, but because the resistance decreased now, it's now to like maybe 2. So my total resistance actually decreases because initially was 3 plus 3, 6, right? But now it's 3 plus 2 because they're in series, so it's just 5 now. So my resistance decreases. What will happen to my current? My current will increase, right? And then afterwards, the reading on the voltmeter, what will happen to the voltmeter? So now I need to find a relationship. You see, D equals to IR. Because now we have voltage, we have current, we have resistance, right? So what happened when my resistance decrease? What happened to my V? Does it increase or does it decrease? Okay, so this one, I usually teach my students one trick. In exam, we have so many things to remember. It's not necessary that you remember the relationship between each of them, okay? So what can you do when you don't remember? Sub in values, and this is a method that has been useful for like all kinds of question and all kinds of formula. So in this case, I want to know whether my voltage increase or decrease, right? When my resistance decreases. I just set a fixed current first. So for example, I set a current of like 5 ampere. Okay, and my resistance now is 3. Then what is my voltage? V equals to IR. V equals to 5 times 3. Current times resistance, 15 volt. Okay, then when my resistance decreases, but my current stays the same, okay, what will happen? So my resistance is now 2. Same, V equals to IR, V unknown, current is the same as 5, and then my resistance is 2. 5 times 2 is 10, so 10 volt. So you realize when my resistance decreased from 3 to 2, my voltage also decreases from 3 to 2. I mean, from 15 to 10. So when resistance decrease, voltage decrease. And in this case, my reading on the voltmeter will decrease because my resistance of the light-dependent resistor decrease. Okay, so my answer will be C. Okay, I hope you all understand. Any question? Okay, if you don't have, just take note. If you don't remember the relationship, even between is like I and R, for example, you don't know when you don't know when resistance increase, what happens to the current? Does it increase or does it decrease? I also don't know. Okay, I can't help you in exam, so you need to sub in values to find out for yourself. Okay, and it will work. Okay, so I'll move on to the next question. Okay, so for this part, it's the same as what we saw just now. Some formulas, V equals to IR, Q equals to IT, which I wrote it as I equals to Q over T. Okay, it's the same thing. And then R equals to rho L over A, whatever I just went through with you guys. Oh yeah, take note, the cross-sectional area, the SI unit is meter squared. And for length, is meter. Okay, then one formula that we didn't go through just now is P equals to VI. Okay, P equals to VI. What's P? P is just power. V is potential difference. I is current. Okay, so we will be using this formula for later also. And it's not very complicated. We will just see the questions later. Okay, so we move on first. For question 15, okay, it's actually very similar to the question that we did just now. That involves the using of R equals to rho L over A. Okay, and I want everyone to try because we went through whatever like similar question just now. And I think you should be able to try this question already. Okay, so you just try now. I'll give everyone 2 minutes to try. Okay, but now take note, they say what is changing? Is it the thickness that is changing or is it the area that is changing? The area was A and it's now 4A. Okay, so you must take note, you are changing the radius or are you changing the area? Okay, so 2 minutes. Okay, so 2 minutes up. Let's just go through first. Okay, R equals to rho L over A. So we all know that this is a formula that we should be using. Okay, so for the first wire, the metal wire, okay, is of length L and a cross-sectional area of A. So it's rho L over A lah. Okay. Second wire, the resistance is 2L, rho 2L over a cross-sectional area of 4A. So this is how it looks like now. This is for the second wire. Okay, so R equals to 2 divided by 4, half rho L over A. Right? So for the first wire, it has a resistance of R. So what happened to my second wire? It's just half and rho L over A, right? Rho L over A equates to what? Equates to my R. So it's half R. And it will be R divided by 2. So you just see. Okay, this one is quite straightforward, like this question. Is there any uncertainty about this question? Okay, then I will just move on. Okay. Okay, for the next part, the resistance and cross-sectional area of the wire changes in going from X to Z. So which row describe these changes? What happened? Okay, so here says the equal length and the same material. But what changes is actually they have the same current also, because if you realize they all end up at the same x-axis, right? Means they all have the same current. But what is different is the voltage, different voltage. Okay, so what we learned just now, V equals to IR, right? V equals to IR, and then what is the relationship between resistance and voltage? We actually sub in numbers just now to find out already. So we found out that they are directly proportional, which means that when my V decrease, my R decrease. Okay, this is something that we found out just now from the calculation over here. Okay, when V decreases from 3 to 2, and then my voltage decreases from 15 to 10. So they are directly proportional. So here, my voltage decreased, my resistance also decrease, right? And then in this case, X to Z, the voltage decrease. So my resistance decrease. Okay, and then my resistance decrease means that my area increase or decrease. Okay, so for this part, just take note. You can actually sub in values into like R equals to rho L over A to find out also like whether when I have a smaller area, my resistance will be higher or lower. You can sub in values, but because of time constraints, so I'll just let you know. In this case, right, you can memorize also like if that's easier for you. Okay, smaller cross-sectional area. Smaller sectional area actually means higher resistance. Okay, higher resistance. So in this case, my resistance decrease, right? Which means that my area increase because they are inversely proportional. Smaller area means higher resistance. Okay, so a smaller area, higher resistance. So they are inversely proportional. Okay. Okay, no question, then I will move on. Okay. For question 29, what is the power dissipated by R2? Okay, so now we see the word power. The word power suggests to us what formula should we use. There is one formula that we saw just now, which is P equals to V times I. Okay, so I only want for R2 in this case. So let me highlight R2 first. I want to find R2. Okay, so in order to find my power, I need to have my voltage, I need to have my current. And what information do I have over here? I have R1, R2, and R3. They have the resistance of 3. So I can find my total resistance first, which is 1 over 3 plus 1 over 3 inverse plus 3. Okay, this is my total resistance, which is 1 over 3 plus 1 over 3 inverse plus 3, which is 4.5. Oh, okay. And then I can find my total current flowing through the entire circuit because I have my resistance, and I have my voltage. Okay, so V equals to IR, my V is 9, my I is unknown, and then my resistance is 4.5. So my I is 9 divided by 4.5. My current flowing through is 2 ampere. Okay, and then you realize I actually can find the voltage for R1. Okay, because for R1, I have the resistance 3, right? And then I have the current 2 ampere. So I can find the voltage for R1. So V equals to IR again. V unknown, I is 2, my resistance is 3. So my voltage is actually 6 volt. Okay, so my voltage for R1 is 6 volt. And then what's my voltage for R2 and R3? I just need to take 9 minus 6 equals to 3 volt, right? 3 volt, take note because they are in parallel. So each of them actually has the same voltage, which is 3 volt and 3 volt. Okay? So after that, I still need to find my current flowing through R2, which I need it to find my power, right? So what's my current flowing through R2? What's my total current now? My total current is 2 ampere, right? 2 ampere. And then do you realize R2 and R3, actually they have the same resistance, 3 ohm, right? When it's same resistance for 2 resistor, the amount of current flowing through is the same. It's the same. They will be split equally in this case, okay? So my total current flowing through, it should be 2, right? And because they have the same resistance, it's split equally. So the amount of current flowing through R2 should be 1. The amount of current flowing through R3 should be 1. And they add up to be 2 when they combine again here. Okay? So my current flowing through R2 is 1. And now I can find the power because I have voltage and I have the current, right? So it's just P equals to VI, P equals to 3 times 1. And it's 3 watt. Answer is A. Okay, is there any questions so far? Can you type into the chat if you have? Well, I explain, just take note, SI unit for power is watt. Okay, which is represented with a W. Okay, I'll put here for like 10 seconds before I move on to the next part. Okay, nice. We will move on. So this part, okay, question 31 and question 25 actually is similar to whatever we went through just now as well. So I will give everyone time to try, okay? So same thing, you look at this power, right? P equals to VI. It's the first formula that comes to your mind when it comes to like power, because that's the only formula that we learn that has power. And in this case, there is resistance, there is a voltage, which allow you to find current, right? V equals to IR. So 10,000 voltage, and then my current unknown, but I have my resistance of 5. So I can find my current. And then they say they have power also, but they want you to find the power in the cable. Okay, so everyone, I'll give your time to try also. And then for question 25, it's the same thing lah. R equals to rho L over A, because it's like wire. They ask you to find resistance for wire, and there is like area, there's length, so you know you need to use this formula. Okay, so I think I will give everyone maybe 3 minutes to try it out. Okay, while I go to the washroom. Okay, so 3 minutes up. Let's just go through. So for question 31, I think it's pretty straightforward, but a lot of students, I mean, some of my students from my previous class, they actually got confused. Like, they know how to find the I right here, just 10,000 divided by 5, because 10 kilovolt is 10 times, 10 times 10 to the power of 3, right? Which is 10,000. Okay, 10,000. And then my my resistance is 5. So it's just 10,000 divided by 5. And I will get my current to be 2,000 ampere. Okay. And then I use P equals to VI, right? P equals to VI. And then I'm supposed to find my power. But doesn't the question already give you power? But there's this misconception. Okay, so in this case, they say power generator has 100,000 watts. Yes, but what's the question asking for? The question is asking for how much power is in the cable, right? So this back part says that the power is transmitted through cable having a resistance of 5 ohms. So you need to use the resistance of the cable into a consideration. So in this case, we have a new power that we are finding. So my voltage is 10,000, which is the same as my power generator. But then, because my resistance of the cable has to take into account consideration, right, which caused my current to be different because of V equals to IR, right? So if my resistance is different, my current is different also. So my resistance is 5 and my current is 2,000. So what is my power? It's just 2,000 times 10,000, which is 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7 watts. 200, yeah, watts. So, but the option says like 20 MW, right? How do I make sure of that? So for this part, I'll just go through a bit. T, there are like the different prefixes you need to remember, right? So, okay, you can like copy down so if you want to. Okay, this part should be in your textbook, but I'll just write it out to be clear. So in this case, tera, giga, mega, kilo, deci, centi, milli, micro, nano, pico, and these are all the prefixes that it represents. So in this case, my answer is 2 with like 7 zeros behind, and the option is mega, right? So I move, if I just 1, 2, 3, 4, 5, 6, 7. So it's 2 times 10 to the power 7. Okay, not 7. 2, 1, 2, 3, 4, 5, 6, 20 times 10 to the power of 6, which will correspond with my M over here, and therefore is 20 megawatts. Okay, so this is how you find the answer lah, by using the prefixes also. Okay, is there any question? Okay, you don't have, then we'll move on to question 25. Let me just shift this part. Let me just shift this part to here. Okay, let's continue. Okay, question 25. So question 25 is quite straightforward like just now. R equals to rho L over A. So my first wire, copper wire, has a cross-sectional area of A and my length has a resistance of R. So another copper wire has twice the length, which is L, R equals to 2L, and half the cross-sectional area, so it's half A. Okay, then 2 divided by half will give me 4. So it's 4 rho L over A. And because my rho L over A equates with my R, right? So it's equals to 4R. So my answer is D. Okay. Any question? Okay, I think it's okay. So same thing, I'll just put here for like maybe 5 seconds, then I'll move on to the next part already. Okay, so for the next part, I think a lot of students are confused, and I think it's the most important part of this chapter also. So, tell you guys about more, then we will end the class already. Okay, so take note. IV graph is what we always draw. Okay, so what is IV graph? IV graph basically is current and voltage, right? One is on the y-axis, one is on the x-axis. And you need to remember when you draw, it's always an IV graph. You don't draw a VI graph. Most of the time, the correct way to draw is IV graph. Okay, but what is this? Like, what does this even mean? Like, there's a line in the middle. So, you see, if we draw a VI graph, right? What does my line means? Actually, my I will mean resistance. Because if you realize, how do I calculate my gradient of my line? It's y2 minus y1 over x2 minus x1, right? Which in this case, won't it be v over my I? And then it will be my r. So this line actually represents my resistance if it's a VI graph. Okay, but because most of the time we need to draw it in IV graph. So how do I find my resistance? It's very simple. Actually, just flip it. So when you draw VI graph, the straight line is the resistance. Then when you draw IV graph, 1 over R. This line will represent 1 over R. Okay, then how do you find a resistance? Maybe now, for example, you'll find your gradient of the line. Your gradient of the line is actually, gradient of the line is like maybe 4. Okay, but does this represent your resistance? No, it doesn't, because this gradient represents 1 over R. So 1 over R equals to 4. And what's my 4, right? And what's my resistance? So my resistance is just 4R equals to 1. R equals to 1 over 4. Just flip it. Okay. So that's just one key point of this chapter. And then we will see here. What is the order of the resistance value of the electrical device at point J, K, and L? So point J, point L, and point K. Okay, so for J, it has 0 current. It has 0 current. Let me write down 0 current. And then for L, it has the highest current and the highest potential difference. Okay, so what is the answer over here when it has like the question is asking for the resistance? So by right, you will feel that J is like 0 current, so resistance will be the smallest. And then L is my highest current, so my L resistance. J, if it's 0 current, means that my J resistance is the highest. Yeah, so it will be like this one. And then for my L, it's the highest current, which means my resistance is the smallest, which is K. Okay, so this is how you might view it as. But in this case, you can actually see from the graph also. So, right, this one is an IV graph. Okay, IV graph. And then the line in between is not the resistance, right? It's 1 over R. So this one means it's 1 over R. So 1 over R, do you realize at L is the steepest? So 1 over R is the greatest at this part, at L. Okay, so what is my R? For example, now my 1 over R is the greatest. 1 over R at L, for example, is a 4. Okay, and this part, my 1 over R is like maybe 2 or like 1. Okay, 1 over R is 1 because it's very gentle, right? The curve is very gentle. So how do I find my R? Flip it, right? So R equals to 1. So I flip the 1. And then for this part, R equals to 1 over 4. So you realize this one is 0.25. 0.25 ohm. So you realize actually at my L, yes, I do have the smallest resistance. And at my J, I do have the greatest resistance. Okay, so this is another way that you can see it but just by saying, oh, this one is 0 current. And then 0 current means the resistance is the highest. Okay, by looking at a graph and interpret it in the way that I just taught you, by flipping, you use the line to find 1 over R. But 1 over R is not your resistance because it's an IV graph. You need to flip it in order to find your R. So in this case, you will get your answer to be A. Okay, any question? So when you draw, right, or when you answer question, really have to pay attention to what kind of graph is being provided to you. Is it a VI graph or is it an IV graph? Because these two different graphs will give you very different answers. But most of the time, if they ask us to draw, we need to draw IV graph. This is the standard way of drawing it. Okay. Okay, if there's no question, I'll move on to the next question in like 10 seconds. Okay. Okay, great. Then we move on to the next question. This one. So the question says, the resistance decreases with the current flowing through it. Okay, this is the main point. Huh? Resistance decreases with increasing current, means there are more current and then there is lesser resistance, right? Let me adjust the thickness. You know what, I cannot. Okay, resistance decrease with increasing current. Okay, so which one of the graph represent how the current varies with the voltage of the electrical component? So now I need to find the resistance is decreasing. Okay, but do you realize all my graph over here is IV, right? So should I find a graph whereby it's decreasing gradient, or should I find a graph that is increasing gradient? Okay, so for this question, let's sub numbers again. I really love to sub numbers. I think it's the easiest way to see. So for this part, for example, my 1 over r is the greatest because my gradient should be the greatest, right? It's the steepest. So my 1 over r, for example, is 4. And for this part, my 1 over r is 1 because it's the most gentle part. So what happened to my resistance? My resistance will be 0.25, right? Because I flip it. I need to flip my 1 over r to find my r. So my r is 0.25. And for this part, I also flip it. Then my r is 1. So do you realize, actually, even though the graph is getting steeper, but what happened to my resistance? My resistance actually decreases. Okay? So from then, you can see option A is a decreasing resistance. And the current is increasing also because it goes from 0 to like maybe 10, right? For example. Okay, then for question B. For question B, this part of my graph is the steepest as compared to this part, right? This part is like almost flat. Almost flat means like almost 0 gradient. So this part, my 1 over r is 1 because my gradient is a less like steep one. And then for this part is a steeper. So for example, 4 again. So when I calculate my r, this part is my 0.25 and this part is my 1. So even though the graph is getting gentler, but my resistance is increasing from 0.25 to 1. Okay, but the question is asking for resistance decreasing. So B is out. And for C and D, right? Okay, this one I want you all to take note. If it's a straight line, you'll realize, for example, this part. How do I find my gradient? Y2 minus y1 over x2 minus x1, right? And how do I find my gradient here? Same thing. Y2 minus y1, x2 minus x1. But if it's a straight line, constant gradient. Straight line means constant gradient. Means that if I take it at like this point A and point B, my gradient will be the same. So it means that my 1 over R1 will be equal to my 1 over R2. This is what 1 over R1 is my 1 over R2. They will be the same. Okay, so if it's same gradient, it will mean that my resistance is the same also. Okay, which doesn't fulfill what the question wants because the question wants decreasing resistance, right? So my answer will be A. Okay, so this is how you break it down and fit the theory into your questions. Okay, is there any question? If not, I'll just give like maybe a few seconds before I move on to the last reading. Yeah, move on to the last question of the day. Okay, don't have. I hope that y'all get it. If not, just text me afterwards, okay? Okay, so last question of the day. Where can Ohm's law be applied for the wire? Okay, Ohm's law. What does Ohm's law mean? If you all don't remember, let's recap, okay? Let's go back up. It was mentioned in the definition, which is this part. Ohm's law. So Ohm's law states that the current passing through a metallic conductor is directly proportional to the potential difference. Basically just means that they're directly proportional lah. Okay, so when current increase, potential difference increase. That's it. And when current decrease, potential difference decrease. So for this part, they are directly proportional. When directly proportional suggests to us, okay, I'm pretty sure you all learned it in your E-math. So when directly proportional, we will know that it's a straight line. Like my gradient is constant. Gradient constant when it's directly proportional, right? Directly proportional means that my gradient is constant. So the answer would just be from x to y. And the answer will be C. And from y to z, you will see that the gradient is decreasing already. Then it's not directly proportional because directly proportional is always a straight line. And it shouldn't be at y only because y is just a point. And the question is asking where can Ohm's law be applied? Is it just at y? It's not. It's from x to y. Okay? So that's about it for this class. If you have any other question, feel free to stay back and like unmute yourself to ask me. Or if you do want to try a real class with us, book a trial class, then you can just scan the QR code over here. Okay, I'll stay until the end. If you have a question, just stay until the end and just unmute and ask me also. Okay, if not, thank you for today, everybody. And I'll send the notes later into the group chat. Okay. Thank you. It was C for the last question. Okay, for the rest that are still here, do you have a question to ask me? Or are y'all just owning it? So you all don't know it ended. Okay, guys, I'll wait until 6. If there's no one say anything, then I'll just end the class. Okay? Okay, so for the voltmeter reading, remain unchanged. I think you mean when the bulb like is broken, right? So if the bulb is broken in a series, it will change because the voltage of the voltmeter is calculated in series is by A plus B plus C, then you get a total voltage, right? But for parallel, they are all the same. Like they don't add up to each other, so it doesn't make a difference. Okay. Let me know if you still don't understand, by the way. Okay, there is Sarah. Oh, okay, so I assume that was the last question, but I don't receive any more text. If you do have any question, still feel free to text me. Okay, goodbye everybody.